So how to survive this mess, right? This mess we're in. And how to use network effects for prosperity, peace, and sustainability. So back in the 70s, there was this limited growth study. This is 50 years ago. And basically what it shows is that within this century, because of the limitation of resources on this planet, we would see a breakdown of the economy, population collapse, skyrocketing of the number of deaths, you know. This is the future that they projected, that they expect until today, basically. And this is one of the reasons why people develop mass surveillance and population control systems, the citizen scores, and all these kind of things, you know. And I'm sometimes wondering, you know, why do you take so much time for your PhD? Because time is running away, you know. We need to get this mess cleared before it really sets in. And you have this opportunity really to make a contribution to change in our society if you're just willing to do so. So if I was a PhD student, I wouldn't just write a PhD thesis, you know. I would use this time and opportunity to come up with new ideas and present them to the world in such a way that they would challenge old paradigms and create a new kind of thinking. And so maybe we have agreed that we would close the laptops while other people are speaking here. So how do we want to change that situation? Either we can do crisis management and basically say, okay, resources are limited and we're just distributing those resources in a way that is controlled by AI systems that know everything about us and those available resources. Or we increase the carrying capacity of this Earth. And then the question is how to do that. Now there are some very interesting network effects that I'd like to mention. So some years ago we have made this computer simulation of a game, a social dilemma game, such as global warming, where we had 4 different strategies considered. Cooperators, moralists, that are cooperators who would punish non-cooperative people, defectors, they wouldn't cooperate, they wouldn't punish, and immoralists who would punish defectors even though they don't cooperate. Now, if you simulate such a setting in a social dilemma situation, and basically what you find is immoralists disappear quickly because, you know, punishing is costly. It takes an effort. And the cooperators crowd out the moralists because also the moralists have this punishment cost to bear. And then what happens is basically cooperators stay with defectors, and we know defectors would exploit the cooperators. So the defectors would basically win this competition. And we would end up with a tragedy of the commons. I mean, basically nobody would cooperate. And that would be hell on earth, basically. Now the interesting point is if we do the very same simulation, just with a little difference where not everyone interacts with everyone else, or with randomly chosen interaction partners, but everyone would interact just with the neighbors, this was happening. So we have now a spatial setting, random distribution of strategies in the beginning, and then after some time you see red is overwhelming, and the newspapers would report defection is taking over the world, you know, that's the end. But actually if you wait long enough, then you see something else happening. Suddenly blue is dominating. And finally green, which is those people who are cooperative and to punish defection. Why is this? Now the point is that we find a clustering effect, and basically the defectors are separating the cooperators and the moralists, which protects the moralists from the cooperators. And on the other hand, the moralists are punishing the defectors, so they have a strategy against the defectors, while the cooperators have not. So the defectors will make the cooperators disappear, and the moralists can keep the defectors in check. This is how basically everything ends just the opposite, as if everyone would interact with everyone else. So the representative agent approach, which is often being used in economic theory, is totally misleading here, right? Neighborhood interactions, also in a social network, can make a huge difference. And yes, there are a lot of interesting things that you can discover. And then of course the question is, do we still have to punish each other? Or are there other social mechanisms that would do the same job and maybe even more efficiently? And the answer is yes. Altruistic signaling, for example, is more efficient than costly punishment. And this is something that Michael Ness found. Just to know, he takes years to publish this, even though the world is waiting for this. Yeah, I mean, in this situation, of course, that kind of knowledge is totally crucial. So what I'm proposing is to use network effects for prosperity, peace, and sustainability. And I'm going to give hints how to do that. I've sometimes shown this video that shows that traffic would be able to self-organize if you just have the right design of those infrastructures, right? Here we have a separation of the different flow direction, and there's a buffer in the middle, and that changes everything. Now, as you know, I've been dealing with traffic light control in cities for some time, back in Dresden. And the interesting point over here is there is not a given street capacity or capacity of the city for traffic flow. It can change. There are all those minimum functions, and if certain kind of events occur, this minimum function is activated and suddenly reduces capacity by some amount. We even know that from freeways, but even more in cities. So if you do things in the wrong way, you can lose a lot of capacity. Now we found a way to use self-organization, as we have found it among pedestrians, to come up with self-organizing traffic light control. So you see the oscillatory flows here. This happens because pressure builds up on one side and it stops the flow from the other side and then changes the flow direction. Now intersections are also bottlenecks, just for more flow directions, and so we have come up with a traffic control scheme where the traffic flows would control the traffic lights rather than the other way around. And you see that there are beautiful green waves that are coming up by self-organization. And now the question is, would it be better than the centrally controlled traffic flows of today? And here is the answer, yes. Now these results, the gray bars, are for a state-of-the-art adaptive traffic light control scheme used by the city of Dresden, which produces green waves and all this. Blue are the results that we found. Much reduced travel times for public transportation. Also some reduction for motorized traffic. Huge benefits also for pedestrians and cyclists, and for the environment too, right? So decentralized can outsmart centralized control, because traffic light optimization is an NP-hard optimization problem, and traffic flow is largely variable, so this cannot be solved by a supercomputer in real time. And so you need to make simplifications, and we basically have a control scheme which locally optimizes flows, but paying attention to the neighboring intersections, right? So this is very important that you not only selfishly optimize, but keep into account the effect you would have on the neighboring environment, right? Now, where would we go within this ERC grant that I recently got? And the team will change its research direction, and so hopefully some of the earlier PhD thesis would be finished by then, and then maybe some of you would get a postdoc position or so. Let's see. Now, the interest is, of course, how will mobility change with self-driving vehicles? Moreover, how could we organize hybrid traffic and logistics of the future, where basically public transport, cars, Ubers, bikes, and logistics is co-organized? And how can we come up with flexible, adaptive schemes where a vehicle would be available at the time when you need it? So you don't have to adapt to a schedule, but a schedule, if there would still be something like a schedule, it would be adapted to you. And I think a combination of those different things would make it possible. And there are also more fashionable devices that we've seen this morning to get from A to B. One possibility really to increase road capacity and reduce traffic congestion would be to use roads in a variable way. So here you can see that was in Washington, D.C. At a certain point in time, you're not allowed to turn left because it disturbs the traffic flow a lot. So by changing the operation, and whether you use roads in a bidirectional way or unidirectional way, or how many lanes you use in one direction versus the other direction, that can change the capacity of a city a lot. And in principle, once we automate cities, these things could be changed in the course of the day. Like with the Golden Gate Bridge, it has a variable use of the lanes in the course of the day. Now also we need to take into account the amount of traffic depends not only on street capacity, but also on apartment costs. If living space is expensive, people would commute, and that produces a lot of traffic. And so the number of available apartments would also make a big difference. That is usually not discussed in connection with traffic congestion problems. No. I mean, in Switzerland, the situation is extreme. Of course, it drives up the costs of rents and of apartments. So from savings point of view for those who own real estate, that is interesting, but it's a logistics problem at the same time, where basically a lot of people would live in apartments that are far away from their workplace. But we could change the situation dramatically by sharing space between living and working. A lot of the space in the center of cities are office spaces, which are not used at night. And where we live, we basically spend our time in the evenings and in the mornings, and during the day those spaces are not being used. So we could have a kind of a sharing concept where we live and work, and this way reduce travel distances dramatically. And for that we would need to have much more flexible uses of office space and living space, and maybe robotic furniture would be the same, that basically reconfigures the room within a few minutes on the push of a button. All of that could be done in principle, and could have massive effects on CO2 emissions, and could increase the living standards of cities altogether. Who wouldn't want to live in the center of a city? if we could afford it. Right? Okay, so far about improvements of cities. Altogether, I think cities would be the main organizational units of this planet in the future, in particular networks of cities. I believe we need to go from globalization to localization. Think global, act local, and diverse, make experiments, learn from each other, and help each other. And this concept is basically applied in the City Olympics that Stefan and I and others have been proposing. These are friendly competitions between cities to figure out new solutions to global problems such as climate change, energy efficiency, sustainability, resilience, peace, and so on. And the solutions would be open source and Creative Commons. I mean, everyone could take them, develop them further, combine them. So every city could learn from any other city, and all the stakeholders could basically add up to the knowledge and the solutions that have been created. So that would allow for combinatorial innovation, and we would make so much faster progress and with diverse solutions, right? And so the exciting thing is this is going to happen pretty soon with the first Climate City Cup that Stefan and Fatime and others in this room are organizing at the moment. We're extremely excited about it, and I hope that will become a global movement, because I believe much more in this than in kind of controlling people and kind of telling them how much bread and meat and gas they can consume on a given day. And if you don't obey this, you'll get kind of minus 200 points in your citizen scores. Or what kind of world would this be? Nobody would want to live in that world, right? So that world that I'm advertising, this is based on collaboration. You know, together we can make it happen. And this is really about making cities smarter. That means not only to automate them, but also to have citizen co-creation and supported with digital and other means. And so we have to upgrade smart cities by collective intelligence. This is what I believe in. So we need to find ways to identify the best ideas and bring them together. Complex problems need to be looked at from different perspectives. And then different individual solution approaches would have to be combined with each other to come up with even better solutions. I mean, if you take the best individual solution and combine it with worse solutions, surprisingly, what we'll find is, in many cases, a better solution. This is the mystery of collective intelligence. And of course, this team has been working on this. So in PowerPolis, for example, you can see the people who were involved in this. Many are still with us, everyone actually. And now one of the questions that we need to address is how should we exchange information, goods and services in the 21st century to benefit nature and humanity best? And in principle, you know, you could simulate these things in a computer with smart learning agents and make assumptions about how they exchange information and how they exchange resources and see, you know, whether this capitalism of today performs best or whether a Chinese system would perform best, or there would be even better systems where there's open source, open data, or something in between. So that's kind of the approach that governments have taken. They combine cybernetics and synergy for CyberSyn, basically centralized control architectures based on all the information that's been collected. But since Stefano Duca's PhD thesis, we know that all the scoring stuff doesn't really work. You know, so forget about citizen scores and all that kind of thing. I should have published that in a more punchy way, I see, really, and buried that scoring stuff forever. The other approach is this combined synergy and cybernetics with synergetics, and this is based on self-organization, empowerment, and coordination, on ecosystem thinking, right? And so the interesting point is ecosystems have learned to make more out of resources by symbiosis, by reuse of resources and so on. And there are different possibilities. So we can have open data, we could open up data with a delay, we could charge something for data or not, you know. And this needs to be figured out. I think there would be much better ways of organizing our economy and society than today. But you know, hey, do the studies, publish about it, talk to the public about it, you know, and don't wait. We don't have time to wait, you know, this needs to happen now. Now, maybe we can learn something from the way ecosystems are working, our bodies are working, right? You don't have to think about every single thing if you move your fingers and, you know, what your different organs are doing. This is happening automatically, like magic. There are many feedback loops in your body that make this happen. A lot of self-realization, but it's multidimensional, right? There's no money that controls what's going on in your body or in an ecosystem. So there are different organizational systems. You know, why doesn't our economy not work this way? And yes, here we go. This is what we want to build. We call it Finance 4.0 or Finance Plus, and this is multi-dimensional in perspective, and it combines the measurement of external effects with feedback effects to create new forces in our economy and thereby push towards a circular economy and sharing economy by a co-evolutionary process, right? And we'll learn a lot more about this in the other talks. And now, importantly, we can also create peace in such a way. Now, we had this paper about the evolution of other regarding preferences. It takes many generations, right? But eventually people learn to be other regarding and benefit from each other and also overcome conflict and cooperate with strangers. So this is what we need to happen for world peace. Can we support this? Yes, in fact, you know, here's a description of an interaction support processor. And basically, the point is really to evaluate what would happen if we do certain kind of things. Would it be just good for one person, or would it be good for everyone who is involved in the interaction, including the nature? And then we should interact or not, depending on the result of that evaluation. And so we could build digital assistants that help us to increase situational awareness and engage into the better interactions, avoid the bad ones, and create interoperability in a diverse world. I also still think, you know, we should build a culturepedia, which brings together the knowledge about the success principles of all the cultures of this world, so we could learn to combine those different mechanisms and come up with new solutions. So the diversity of cultures is a huge asset if we learn to do this. Why is it not happening? So that can be started. And we could have digital assistants, augmented or mixed reality, to help us interact in better ways with each other and with nature. So network effects make all the difference. We experience now a transition from a component-dominated world to an interaction-dominated world. Don't be confused by what you're seeing. They tend to be focused on people, on political parties and companies and all these kind of things. What really matters is what happens between those entities. The network effect that you don't see. So if we learn this, then we can learn use combinatorial innovation to boost the economy. We can use collective intelligence to help our society come up with better solutions. And we can come up with a multidimensional real-time feedback and coordination that helps our nature. So these will be the success principles of the future, I believe. And so this is what we should be doing.